Similarity in polygons is day 3. We're on day 3, aren't we? Yes. Okay. So the symbol for similarity is this little squiggle line, versus the symbol for congruence was the equal sign with the squiggle line. Okay. What does similar mean? Anybody know what are we saying when two figures are similar? What do you think, Mary? Okay. So the shapes are, yes. What else can we say, Gabby?
The angles are equal, but the segments, they don't have to be equal. They have to be like proportions.
Okay.
2 to 1 or something like that.
Right. So similar means all sides have the same proportion. In other words, one side is 1/2 of the other, and they're all in a 1:2 ratio. Okay. However, the angles are congruent. So remember when we were trying to prove triangular congruence, which one did not exist that you always wanted to tend to use? And this is why, because I kept saying you could have this teeny tiny 30-60 and this huge 30-60-90 degree triangle, and they were not going to be congruent because you were not guaranteed that your side lengths were the same length, or the sides were the same length. All right, so what does congruent mean? Congruent implies that the angles are all congruent and the side lengths are also congruent. And so, yes, do you want these in your note cards? Absolutely. These are ones that need to go on note cards. And so we needed to find something also that's called a scale factor, which I don't really see that I did put this on here, but I want to talk about it. Scale factor. Scale factor is the constant that keeps the figures similar. And yes, that goes in there too. We're going to want to make sure that we're always, when we're figuring out that scale factor, that we're always going to go from figure A to figure B, that we're not going to flip-flop them and go B to A in one case. All right? Similar. Sorry. So list the angles that are congruent. Well, let's look at this. And this figure here is saying that ABC, triangle ABC, is similar to triangle FED. And that statement, like the congruent statements, will tell you what's going to match up. So angle A is congruent to angle what? F. Angle B is congruent to angle, and angle C is congruent to angle D. Similar. All right, so let's check the scale factors of the sides. Again, this statement will tell us how to set up our sides. AB is going to correspond to FE. So that means AB's length is 25 and FE's length is 15. And that reduces down to what? 5/3. This is a scale factor. It's always in reduced terms. And if these figures are truly similar, so unless I made a mistake, we should get the same scale factor when we compare the other two sides. Okay? So then we'll do, well, let's see, BC to what? ED. BC is 30, ED is, what does that reduce to? 5/3. So far, so good. What's my last comparison going to be? CA to DF. CA is 20, DF is, and both are reduced by 4, which gives me 5/3. Now, the statement said that they were similar, so hopefully I hadn't made a mistake. Yes? Mhm. Mhm. All right. All right. So write this statement of proportionality. AB over FE is equal to BC over ED, which is equal to CA over DF. Just check something. And then that would say then, well, that would be the statement of similarity. Right. That's all. Okay? All right. Polygon GHIJ is similar to KLMN. Find the scale factor. And then find X. So GH has to be compared to what side on the other smaller figure? All right, well, that's nice. GH over KL is possible. All the information is given. 12 over 6 means our scale factor is 2 to 1. It's a ratio, so you want a numerator and a denominator. All right, how am I going to figure out what X is then? Remember, the scale factor is what keeps my two figures similar. And it should exist between all the sides, all the comparisons of sides. Hannah? Well, we're going to set this up as a proportion, so what would you say? You're right, we will. Okay? Yes, x over 4 equals 2 over 1, and so x equals 8. So you show me that work. Intuitively knew that you had to multiply by 2, but show it to me. All right, if the scale factor between two figures is 1 to 1, what can we say about the two figures? They are congruent. All right, determine if the polygons are similar. All right. We have sides here of 12, 33, 27, and 30. Here we have sides 22, 18. Is that 20 or 26? I can't tell from my handwriting. And 8. Okay? So if we're trying to determine if the polygons are similar, we're going to have to go smallest side to smallest side, right? And see what that scale factor is. All right? We're not going to go smallest side of one to the biggest side of the other, are we? That doesn't even make sense. So if I were to compare 12 on the first, which is RU, what would I compare it to on the other? Which is 8. And that reduces down to what? 3 halves. Okay? So that was RU over DG. Okay. Then I could do, what's my next biggest one? 27? Yeah. So I could do 27 over what? 18. And that reduces down to what? 3 over 2. And right now we compared ST and EF. Okay, so far it looks good, right? But just because 2 of them work doesn't mean that the other ones are going to work. So we have to do this comparison for all of them. All right, so then we'll do, well, I think that is a 20. Let's do 30 over what? 20, which is 3 to 2 also, and that was a comparison of RS and DE. And then the last one is 33 over, which is also 3 over 2. And so this was UT over GF. So would you agree or not? But if any one of them appeared to be something other than 3 halves, we would have had to have said no. Okay? All right, what would our similarity statement be then for this one? If I said TU is similar, what would I say it to? D, E, F, and G. Okay? Uh-huh. Oops. There we go. Who needed more time? Are you good? Okay. All right. All right, so what's the scale factor on this one? You do this one yourself. Find the scale factor and find x. Show me mathematically how to do this one. What was your scale factor? 2 over 3. What was x? Okay. Find the perimeter of both figures, which means we got to figure out the missing lengths, yes? Okay, so this is 12. Anybody know what BC is? You would say 2 over 3 is equal to y over 9. What does that make y? 6. And if we let this one be z, I would say 2 over 3 is equal to z over 12. And what do we get z to be? Okay. And the perimeter of A, B, D, E is what? Oh, we need ED still, don't we? All right, so for ED, we would say 2 over 3 is equal to, perfect, over 15. And we get W to be, oh, that's a 2. Thanks. Okay, so now what's my perimeter? 20, 30, 46. Did I do the math right? What's the perimeter for this one? F, G, oops, H, I, K. Anybody know? Thirty, 60. I got 69. I got 69. 30. 30 and 30 is 60, and 60 plus 9 is 69. You forgot about the 9? Don't forget about that. Can anybody reduce this down for me? Oh my lord. That's not a triangle. That's not a triangle. It's a quadrilateral. It's a polygon. It's not even a quadrilateral. It's a polygon. All right. So theorem. All right. Here we go. Theorem for perimeter of similar figures. Want it in your note cards. If polygon ABCD is similar to polygon LMNO, then the perimeter of ABCD over the perimeter of LMNO is equal to the scale factor. Always and forever. Mm-hmm. No, it's right or wrong. There's no gray. Okay, here we go. I am giving you the statement that those two triangles are similar, which means all of the lengths have to be in the same what? Scale factor. They all have to be equal to the same scale factor, right? So that means 30 is going to go to what? Okay, MN, which is 30, goes to RS, which is 20, which tells me, again, that my scale factor is 3 over 2. I could have picked NP. NP of 27 over, yeah, I don't know what that is, ST. And again, they get 3/2. My question is, what is this NL called? We just got over this in the last. Well, so the question down here is NL the perpendicular bisector? And where are we? Okay, but what about the converse? What's the converse say? Are these congruent? So therefore, this is not a perpendicular bisector. It is simply an altitude. And why or why not? 30 doesn't equal 27 by the converse. What do we call it? We call it a altitude. All this stuff comes back and haunts you. Okay. Okay, so back to the question. How do I find NL, which is this little value right there? How?
You have 14, LS is 14.
Uh-huh. So tell me what to write. X over 14 equals? Yeah, good. 2x is equal to 52, so x is equal to? Oh, gosh. And I can't multiply. Okay, 21. We good? I know. Okay, here we go. Last one, I believe, yes? Triangle JKL is what? Similar to triangle EFG. Find KM. No, by the way, what do we call KM? KMN. Yeah, sorry. What do we call it? 48, 35, 40. You know what? We'll do this. Is it? Oh, okay. Sorry. So what do we call KM? It's the median. Why do we call it just the median? Because there's no right angle. But what does it do? Bisects. Exactly. All right. Huh? Yeah. Just change that M. All right. So we need the scale factor. What's the scale factor? Why? 48 over 40. If this is 48, then this is 48. If this side is 40, then this side is 40. And so this reduces down to what? 6 over 5. So 6 over 5 is going to equal x over 35. So 5x is equal to, is that 210? Right? And that's going to be 42. Are we all good on this? Scale factor, SF.